Welcome to another episode of Crimes Notes. You guys have learned how to graph inequalities, and so now that you know how to graph them, we're going to look at the difference between solving an inequality equation versus solving a real equation. At the top it says, remember the goal of solving an inequality equation is to. This is not any different than any normal equation. So the goal is to get the variable by itself. That's our whole goal every time. And the questions that we ask ourselves when we're solving 1- and 2-step equations with inequalities is also not any different than what we would do if we were just solving a normal equation. So the first question is always going to be, where's the variable? In other words, is it on the left or the right? So we can draw that line down the middle. What is with the variable that needs to be moved? And then what is the opposite operation of that? So getting the variable by itself was the same. The questions that you ask yourself to get the variable by itself is the same. But if you notice, we've got the biggest thing to remember. If you have a highlighter, I would suggest highlighting this. The biggest difference, or the biggest thing to remember with solving inequalities versus equations, is that if you multiply or divide by a negative, then you must reverse the direction of the inequality symbol. Meaning that if it was less than, it becomes greater than. If it was less than or equal to, it becomes greater than or equal to. That's what reverse means. Okay? And this is what you figured out in that lab that you were doing. All the ones that were false were multiplying or dividing by a negative. And in order to make it true, I had to reverse or switch the inequality symbol. So again, if you multiply or divide by a negative number, then you must reverse the direction of the inequality symbol. And yes, we're going to write it one more time because it's the biggest thing to remember with inequalities. If you multiply or divide by a negative number, then you must reverse the inequality symbol. So let's see what this looks like. So let's go ahead and fold our paper. And we'll start working on the bottom here. So the directions say solve each inequality and graph the solution. So you can still draw the line, but instead of representing an equal sign, it's going to represent whatever symbol is already there. So in this case, it's a less than symbol. Then where's the variable? Here it is. What needs to be moved? This -2. And what's the opposite operation? Plus. So we would say +2 plus 2. And what we do on one side, we always do on the other. The -2 plus 2 cancels because it makes 0, and I have y. The line, remember, represents less than. And then 6 plus 2 is 8. So now the variable's by itself. So this is my answer. Y is less than 8. So to graph that, remember we look at the symbol first. Is it going to be open or closed? Well, since it doesn't have the solid bar, we would say that it's open. So on our graph, we would put open, and then we always label it whatever our answer is. And then we could go ahead and put our test number up there. So as always, I'm going to go ahead and use 100. So is 100 less than 8? No. So that means I'm going to go the opposite direction. So I'm going to shade this way. Good. So then I'm going to leave number 2 for you. Use this one as your example and see if you can't solve that one and then graph. Okay. Let's go ahead and look at number 3. On number 3, we go ahead and draw the line. Then here's the variable. This -8 is what needs to be moved. But remember, we've got a number squished right up next to the variable. So that means this represents multiplication. So the opposite is to divide. So I divide by a -8. Now that sounds familiar. When I divide by a negative, I'm supposed to reverse the direction of the symbol. So if we go back to this problem, okay, I divided by a negative and a negative. So that means instead of writing here a greater than, I'm going to write less than. So because I divided by a negative, I had to reverse the symbol. So now these would still cancel, and I have P. And then less than, I would do -32 divided by -8, and I would get +4. So now I'm ready to graph. Again, it doesn't have the solid line underneath, so I would do an open circle. It is 4. So then I could go ahead and use my test number. So if I put my 100 over here, is 100 less than 4? No. 100 is not less than 4, so I would shade away. Good. All right. So let's go ahead and look at number 4. On number 4, we would go ahead and draw our line. Then we'd get to do fractions first. So anytime we have a fraction, remember we multiply by the denominator. In this case, the denominator is 4. So I'm going to multiply everything by 4. So I would do 3/4 by 4, and then I would do 18 by 4. So for some of you, you recognize that it cancels. For some of you, you do not. So let's go ahead and try multiplying. So 4 times -3/4. And I get -3. So this is -3m is less than, and then we do 4 times -18, and we get -72. And then remember, for some of you, you know that this cancels with this, and that we were left with this, and that's how we get it. But either way, you'll get a right answer. So it either cancels or multiplies, but don't do both. From this point, here's the m. We're supposed to divide because it's a number right up next to a variable. So I divide by whatever's there, so by -3. Well, that should sound familiar again. If I divide by a negative, then this symbol has to change. So it would go from less than to greater than. And so now I have m, because these would cancel or divide out, and then -72 divided by -3 gives me 24. So now I'm ready to graph, but this time I'm going to let you guys graph because we've done a lot of practice on that. All right. Number 5 is pretty basic, so I'm going to let you guys do that one on your own. I'm going to come down here to the bottom set of problems. And let's look at number 6. Okay. For number 6, the first thing that we're going to have to do is distribute, because we don't have fractions. And then we could go ahead and draw our line. So I've got negative 12 greater than, and then negative 2 times p. Remember, there's that imaginary 1 right here. So that's negative 2p. And then negative 2 times 15 is negative 30. From there, I'm going to go ahead and let you guys solve. We're going to start by moving the 30, so plus 30. But don't forget, when you divide by this negative, you must reverse the sign. Good. Now let's look at number 7. This one's really, really different because normally I would draw the line and most of us would draw it right here. But the difference is that now I've got a second quote-unquote equal sign. So I would actually still have to draw a line here. Now, the goal of any equation is to get the variable by itself. So I am still trying to get the x by itself. And this 3 is what still needs to move. But the difference is we always say what I do on one side, I do on the other. What I do on one side, I do on the other. But now I have two sides. So when I'm trying to get this x by itself, and I would say I need to subtract 3, I also have to do it on both sides of both lines. So I would have to do minus 3 here and minus 3 here. So when I do that, this does cancel, and I now have x in the middle, and then I still have both of my inequality signs. So now I could complete it by saying negative 6 minus 3 is negative 9, and 10 minus 3 is 7. So this is actually one of those compound inequalities that you guys should know how to graph. We've got x in the middle, so we know we're going to shade one way or the other. So they're either both going to go out or they're both going to come in. So let's start. We're going to do a closed circle down here for negative 9 because we have the solid bar underneath. And then an open circle up here for 7. And then let's go ahead and put our test number up here. So is negative 9 less than 100? Yes. So that means we would shade this way. Well, if that one goes towards the 7, we pretty much know the 7 is going to have to come back towards the 9. But let's check. Is 100 less than 7? No. So we would have to go away. So this would shade between. Good. So I'm going to get you started on number 8. Actually, I'll probably do number 8 just because these are different. So here's our variable. We know that in order to solve this, we need the 7, or the negative 7, and the negative 2 to go away. So remember, when we're doing this, move that up for you, Sam. We're going to go ahead and move the 7 first, so I would do plus 7, plus 7. But I also have to come to the other side of this line and do plus 7. So this does cancel, it makes 0, and I have negative 2x in the middle. And then I have the less than and my less than or equal to. And now I'm ready to do negative 5 plus 7. Well, that would give me 2. And then over here, 3 plus 7 is 10. So now it's time to get the x by itself. We have a number sitting directly next to the x, so I have to divide, but I'm dividing by a negative 2. So when I divide by a negative, I have to reverse the signs, and this means both of them. So that means this one becomes greater than or equal to, and this one becomes greater than. So now 2 divided by negative 2 is negative 1. These would divide out, leaving me with x. And 10 divided by negative 2 is negative 5. Now, up here, notice we had 2 less than 10, which actually makes sense. 2 is less than 10. Down here, if I'd left it as less than, it would be incorrect because negative 1 is bigger than negative 5, which is why when we divide by that negative, we do end up having to reverse the symbols. Okay? And then I'm going to leave that one for you guys to graph. So good luck, and if you have any questions, make sure you ask.